Good morning. In this course, we're gonna leverage in data interoperability extension using ArcMap to enable you to directly read, translate, and transform spatial data according to independent needs. So you can work in different formats. This extension based on FME has three key features: direct data access, enable ArcGIS directly read data from JS, CAD, web database formats. Can do quick data translation. So ETL means extraction, transformation, loading process. And now I have to install data interoperability. And in this, while waiting for this, in this exercise, the City Hall has tasked you to keep track of the city parts and give the format as a tab file, mapping info file. If you want view into ArcGIS map, archive loss, you need to build a data interoperability connection. But keep in mind it's read only. Now I can activate data interoperability. You can add a connection. Search map info. Click OK. Find the dataset. Sorry, just I just want the wrong one. Okay. Click OK. Now we can view everything. The data interoperability extension will index this and determine which feature class are populated. Refreshing the connection will remove the empty feature class. That's why you can see the one I couldn't load has been deleted. So now use data interoperability tools, and you can do a quick import. We need to create a photo connection first. Expand the city parks dot. So notice the reader is a shape file, and writer is a gigabit API. Now I just made a tool, and the way you open it is to click the edit button. Just open FME software. Now we only want the east point, so we're gonna delete the one contains the west. Because I only want one feature type, output data set to represent all east layers. Or later you merge all east layers into one unified feature type. So you just drag like this. Change the name, boundary east. Click user attribute. Remove everything except for population 1990. Now we add a new population 2020, extreme always rate. Distance 0, expand this unit. And we can expand it. As you can see, there's only 2 fields left. Right click, edit value. Currently we set -1, but we'll calculate later on. And now we run workflow. Change the name, boundary right GML. So in this case, if you have an inspector right beside the reader type, every time after running the algorithm, it will just show the inspected results, separately. It is a more comprehensive way to demonstrate each dataset. Now the next step to transform the content. In last step, we only changed the schema of dataset. Click transformer menu, add transformer. In the last step, we create the special ETL tool, which is this one, contain population data, because we change the schema. Before transformation, it contains lots of different fields. After, ignore the middle part transformation. We're just doing the basic. I was just saying the step before adding transformation. So we put a bunch of attribute fields and reducing to 1 or 2 fields that were currently focused on the population growth. Because we create the second field, which is population 2020, and we know that as a growth rate, which is 60%. So we can use expression evaluator transformer to calculate a value for 2020 attribute. And I just add a transformer and I just made a connection and double click the transformer. We can adjust parameter. This is expression, new attribute, change the name to published in 2020. Thus, we can build OK, and the published in 2020 field can be executed and calculated. And you can see the new field has been calculated and adding to our output writer feature type. So I couldn't find the inspector, but it ended up just having click to inspect catch features. Now we're creating the second spatial ETL tool, and this one's a geometric transformation because we want to find where the bridge exists. By doing so, we intersect the road and river line geometrics in this dataset. That's a river, that's a road. And we're gonna add some transformation to find out where the location of the bridge. And the output is gonna be a MID format. And the current output is gonna be, I mean, it is the replica of the input, so it's not useful. So we already delete one of the feature type and rename the second one as bridges. And now we insert a transformer, intersector, and do some drag and drop. Double click this transformer, accumulate mode, merge attributes. The whole logic of this process already finished building, but so I can just tell you like that's the river, that's the road, and the attribute creator it's just like adding another field into this table, so it's called attribute creator because we won't add a flag, so we just put each attribute creator, we just add a new attribute field into this, into the separate tables and give the flag. The row flag is true, and intersector is something can intersect everything. It's like they don't care if it's like road intersected or river intersected. The algorithm gonna focus on every intersected point. So that's a problem. So because we're focused on the bridge, but what if there's that's a road and the road intersects each other, but it's not bridge. If there's a river intersect each other, but it's not bridge. So we cannot merely read out the intersector. Thus, we create extra field to label every input. So every time the algorithm extract a row of line, okay, so it can tells you, okay, well, that's a road flag, which is true. And we go on the tester, you see the end, so you have to make sure the road and the river both become true. It is not like road and road is true, river and river is true. It must be different, but also true. Well, there's no false anyway. So that's why we can filter this outcome of intersector. So like we can only focus on, okay, well, that's a bridges. And the function of attribute keeper is make sure the attribute from those table is intact. And that's whole algorithm, and we can click run. And select the same folder as input and click run. And you can see that's the point. It's very good, very very good. So we uh, as you remember, the output is the MF format. The process to, if you want opening a map to like visually inspect how it looks like, you can only import one by one because we're leveraging the data interoperability connection functionality. So I already add road line, bridges, and now we add a river and make sure the format is correct. Okay, because every time you made a connection, it's gonna include everything in the folder, but it is not valid. Like only the one you're importing is valid. So we do refresh and drag and drop. So that's great. Now we can change the symbology. And you can see every intersect point, not self-intersect, but every intersect point has been visualized by the FME software. Congratulations, that's really big. So in this tutorial, we leverage data interoperability to so we're able to load any format of data into the ArcMap. That's the first takeaway. And second one is we can leverage the FME tool to build the customized workflow that can execute the data transformation and data extract and load process using FME software.